Hey everyone, it's John, and today we're going to continue on the Key Concepts video series where I try to break down some key concepts of IP routing protocols in quite a short space of time so you can get a rough overview and use this video series as a supplement to your actual textbooks to help you maybe better understand the technology. Okay, so in today's video we're going to be focusing on the operation of DUAL, how EIGRP uses DUAL, and the EIGRP packet types. So with that said, let's kick on and let's do it. Okay, so let me just give a brief overview of what we're going to do quickly. So here's the topology here. The router we're going to be focusing on really is router 3, okay? And there's going to be a loopback of 7.7.7.7 on router 7 here. And what we're going to do is just do a little bit of manipulation to see how we can get to that and see how EIGRP reacts in different situations using successors, feasible successors, then losing that route and having to go through the query process to find a new route to get to that network, okay? So that's just the basic overview, so let's just go and configure it then, okay? Okay, now to keep this as simple as possible, let's just focus on two routers and we'll pick router 3 and router 4. Now the first thing you need to know is that EIGRP, well an EIGRP speaking router, is going to build its own local topology table, and you can think of that as when you type in the network command, okay? The next thing it's going to do, it's going to seek to establish a neighbour relationship. Now to actually have this neighbour relationship, we need to have some matching parameters, and those matching parameters are they must be advertising the same AS number, the same autonomous system number. They've got to be on the same subnet. They must have matching K values. By default, you're just going to be using bandwidth and delay, okay, which is the first and the third one. And the authentication must match if that's being configured, okay? Okay, and now once we actually have that neighbour relationship established, what's going to happen is the neighbouring routers are going to share their full topology information with one another, okay? Once they've done that, once they've given their full information, the only time they're going to be exchanging information is through partial updates. So for example, when a change is happened in the network, which is going to trigger a change. So that's the difference. Usually in distance vector like RIP, we're going to have a timed update, like every 30 seconds, send the full information. Not in this case. We're going to establish the neighbour relationship, and then after that, it's going to act kind of link state-ish, okay, triggered updates, okay, and only partial. So if a link fails, it's going to inform the other device that, by the way, a link I'm connected to has failed, or we've got a link recovery, or a new neighbour's advertising new topology information, so on and so forth, okay? Now, another thing you need to remember is that the split horizon configuration is actually going to limit where updates are sent where, okay? Because that's, remember, our primary loop prevention mechanism in distance vector. So if we receive a route on one interface, that router's not going to re-advertise that exact same route back out of that same interface, okay? So just remember that and just keep that in mind. Okay, so what EIGRP is going to use, it's going to use 5 packet types. Now let's just briefly look at them. Now, you can roughly remember this by kind of saying the word hacker. It almost kind of sounds like it. It's like hot hacker. Okay. Not quite hacker, but a wee bit like it. Okay, so the first one is a hello. We've also got an update. We have our acknowledgement, our ACK. We have our query, this is an important one. And we have our reply packet. Now, it's important to discuss what each one does, what its function is, because each one is important, and I think it will really help you understand the process of EIGRP and why it's important to use things like summarization and stub routing and so on and so forth. So let's just go through them now, okay? So I'll just clear this first. Okay, so the first packet which is going to be sent is the hello packet. Makes sense. Now that's going to be multicast to the address 224.0.0.10. Now try and remember that. And what that hello packet is going to do, it's going to be used to discover and verify neighbour routers. Okay, that's the purpose of that. The next thing is the update packet. Effectively, that's going to contain your topology information, prefixes, prefix length, your metric components such as bandwidth and delay. This is a common misconception, okay? Remember that MTU is actually included in the topology updates, but it's not used for the metric calculation. That is a common mistake, so just really try to remember that, okay? Now the next thing is the ACK packet, so let's talk about that. Super simple, don't overthink it. It's just exactly what it sounds like. It's an acknowledgement. Many of these packets are sent reliably. They're waiting on an acknowledgement that they were effectively received. The ACK packet will do that for you, okay? It just basically acknowledges that the packet has been received. Now, the next one is the query packet, possibly the most important one to understand from a stability point of view in EIGRP, because understanding query propagation is going to really impact things like convergence time and stability, like I say, because you're going to actually have to implement strategies like summarization and stub routing, and we'll get to that later. But just understand is that these query packets are sent out, they're multicast rather, when a route is lost and there is no feasible successor. It's known as going active, okay? Now, active might sound like a good thing and passive might sound like a bad thing, and EIGRP invert that, okay? Going active, effectively think about it like you've lost your mobile phone and you're frantically and actively looking for it. You're actively searching under the couch, under the table, everywhere. That is what's happening when you're going active in EIGRP when it's sending out query packets. Now, the response to that query, if a route is lost and an EIGRP speaker starts sending out queries to neighbours saying, do you have this route? I've just lost it. If a speaker does have that route, it's going to send a reply packet to it, and it's going to say, hey, I've got that route, use this one. And that is all the reply packet is doing. So we've got our hello, we have got our update, we've got our acknowledgement, our query, and the reply. That's the basic overview of them. And again, dig into your textbooks to get more information on each of them, but that's the rough overview. The next thing is we're going to be looking at DUAL, how it uses 3 different tables. Let's look at them now. So like I said at the start of the video, we're going to use router 3 to ping the loopback of router 7. I have manipulated the bandwidth and delay manually to ensure that the path via router 4 up the top is the best path there for the successor route. The middle path is a backup route because it has met the feasibility condition, therefore it's a feasible successor, and the bottom path via router 6 is not a valid backup path because it does not meet the feasibility condition, okay? So let's look at the 3 tables we need, okay? So the first one is the neighbour table, and we should see 5 neighbours here. So if we do a show IP EIGRP neighbours, and we can see that we do in fact have 1, 2, 3, 4, 5 neighbours. If we do show IP EIGRP topology, we'll see our second table, which is the topology table. And if we just focus on the route for 7.7.7.7, we'll see that we've got one successor route. Its feasible distance is 131.072. And you'll actually see that this one here is actually a feasible successor, i.e. a backup, because its advertised distance is less than the feasible distance of the successor route, therefore it's a valid backup path. But you'll notice if we look at the third table, the show IP route, there only is one entry for 7.7.7, which is the best route, which is the successor, which is through gigit02. And if we ping that, all the 7s, we can do that. And if we shut that down, the feasible successor should kick in immediately. It should be immediately installed into the topology table. If I do a show IP route now, you'll see that we're straight now going out of gigabit 03, and we can still ping that. Okay, now what would happen if we now shut the feasible successor down, which is gigabit 03? We shut that one down, effectively, because 4 and 5 are now unreachable, the successor and the feasible successor, router 3 will now query its neighbours to get a route for router 7. What's going to happen is 1 and 2 won't know a route, but 6 will give back a reply saying, I know a path to get to 7, and we'll see that if we actually look now, we do a show IP routes, we can actually get there through gigabit 04, and if we ping there, we've now got a new path, okay? Because we went through that query and response, okay? So that is the basic overview of how EIGRP uses different packet types, how it uses successors, feasible successors, and the 3 different tables to effectively route traffic in an EIGRP network. Okie doke. So that's the end of the video. Thanks very much, and I'll see you guys soon.